Okay, let's explore this. You've been tracking Tesla's FSD development, right? And you flagged some really interesting sources about their next-gen hardware.
That's right. Specifically, the hardware rumored to be called AI5. It feels like the timing is pretty critical now.
Yeah, definitely. So today we're doing a deep dive into AI5. We've got this Korean news report from MK, some chip manufacturing insights.
And the goal is really to understand what this AI5 chip means, for the future of self-driving.
Exactly. How powerful is it really? And maybe most importantly for listeners, what does it mean if you own a Tesla today?
Well, the context here is FSD V13, the latest software version. It seems like it's really starting to push the limits of the current hardware, the AI4 chip.
Ah, okay. So the software is getting ahead of the hardware almost.
In a way, yeah, which makes this AI5 news, especially the MK report, very timely. It suggests Tesla's gearing up for production.
And the headline number is this performance target, right? What was it in?
The target mentioned is between 2,000 and 2,500 TOPS. That's quite a number.
Okay, hold on. TOPS. What exactly is a TOPS? Sounds like something out of a spy movie. And how much does that raw number actually tell us?
Huh. Yeah, it does sound a bit like jargon. TOPS just stands for trillion operations per second. It's essentially a raw measure of processing power, specifically for the kind of math that neural networks do.
So like the AI's IQ score, kind of, or maybe more like raw computational muscle?
More like raw muscle, yeah. More TOPS generally means the AI can process way more information simultaneously, letting it think faster, handle more complex scenarios.
Okay, so you need the muscle, but the software is still the brain that uses it.
Exactly. Raw TOPS is just the potential. You absolutely need sophisticated software to make use of it effectively, but you can't run tomorrow's complex software on yesterday's hardware. You need that capacity.
That makes sense. So putting that 2,000 to 2,500 TOPS number into perspective, how does it compare, say, against other chips we might know, or even Tesla's older stuff?
Right, good question. If you look at, say, NVIDIA's latest gaming GPUs, the RTX 5080 is reportedly around 1,800 TOPS, and the big one, the 5090, might be up near 3,400.
So AI5 sits right smack in the middle of high-end gaming GPUs. That's pretty impressive for a dedicated card chip.
It really is quite a feat, and compared to Tesla's own history, well, HW3, which many cars still have, was 144 TOPS.
Wow, okay. Big difference.
Huge. And the current generation, HW4 or AI4, is around 500 TOPS. So AI5 is aiming for a 4 to 5 times jump over even the current hardware. That's a massive generational leap.
Now, I vaguely remember Elon Musk talking about even higher numbers in the past, maybe like 5,000 TOPS. Does this report contradict that, or is something else going on?
That's a really interesting point. It could be about how performance is measured. See, Tesla's FSD computer isn't a general-purpose chip like an NVIDIA GPU. It's an ASIC.
An ASIC, application-specific. Something.
Application-specific integrated circuit. Basically, it's custom designed to do one job and one job only. Run Tesla's FSD neural networks.
Ah, so it's not a Swiss Army knife. It's more like a specialized surgical tool.
Precisely. And because it's so specialized, it can be incredibly efficient at that one task. Tesla might measure its performance in a way that reflects that optimization, which might not directly map to how, say, NVIDIA measures a general GPU. So the numbers might seem different, but reflect different kinds of optimization.
Okay, that clarifies things a bit. So this specialized, super powerful chip, why the huge jump in power now, is current FSD really that limited? It seems pretty capable already.
Well, it's capable, yes, but think about the ultimate goal. Fully unsupervised driving, robo-taxis, that's a whole different ballgame than driver assist.
Right. It's not just highways anymore. It's chaotic city streets, unpredictable pedestrians, weird intersections.
Exactly. Handling those edge cases, the truly unexpected stuff, requires vastly more complex AI models. You need bigger models, more memory, and the ability to make split-second decisions based on tons of input.
You can't just freeze the frame when something weird happens. The reaction has to be instant.
Instantaneous and critically reliable. This leads to the idea of the March of Nines, moving from 99% reliable to 99.9%, then 99.99%, and so on. Each 9 you add gets exponentially harder.
And that requires more computational power to run redundant checks, more complex models.
Yes, you need the power for that level of perception, prediction, and decision-making, especially when the human isn't the backup anymore. That's the leap AI5 is designed to enable. It's for the jump to true autonomy.
That makes the need for power much clearer. What about actually making these chips? Any word on the supply chain? That's always a potential bottleneck.
The rumor mentioned in that MK report, I believe, is that Tesla might be using both Samsung and TSMC.
Oh, interesting. Dual sourcing.
Yeah, which would be a smart move.
Yeah,
It helps guarantee supply and reduces risk if one manufacturer faces issues. Building these advanced chips at scale is complex.
definitely. Okay, so this brings us back to the listeners. If you have a Tesla now, what does AI5 mean for your car? Especially if you're driving an older model, say with HW3.
Right. So if you have a newer car with AI4, you're likely fine for the foreseeable future. That hardware still has headroom. Tesla's stance seems to be they'll only push upgrades if the existing hardware cannot safely run the truly unsupervised FSD when it's ready.
But HW3, that's the bigger question mark, isn't it? It was initially called Robotaxi Ready.
It was, but FSD V13 seems to be really stretching its capabilities now. Given the power demands we just discussed for real unsupervised driving, it seems, well, highly probable that HW3 vehicles will need a retrofit to get there.
A retrofit with AI5.
Yeah,
Or maybe a version of it.
likely a version of AI5, perhaps one designed specifically to fit the power and space constraints of the older cars. Maybe a slightly lower spec version, but still a massive upgrade from HW3.
And for AI4 owners, maybe something similar down the line, years from now.
Potentially, yeah. If future FSD versions demand even more power than AI4 can provide for full autonomy, then maybe. But that seems much further off. AI4 is still very capable.
So summarizing this, AI5 isn't just a faster chip. It's the hardware foundation Tesla sees as necessary for that next monumental step in FSD. Handling AI that's way more complex than today's.
Absolutely. It's about enabling that leap in perception and reaction, getting closer to that near-perfect reliability the March of Nines needed for true self-driving.
So for you listening, AI5 seems crucial for Tesla's ambitions, especially in complex urban driving without supervision. Which leaves us with a final thought.
Yeah.
With hardware evolving this fast, is the main bottleneck to fully autonomous driving going to be getting enough of these powerful new chips into cars? Or will clever software breakthroughs still allow major progress even on slightly older hardware? Where does the balance lie going forward?